The lecture for today is known as decision analysis. Decision analysis. What is that? What is decision analysis? Well, that's the topic we're going to look at today. Everybody decides. We all decide, but before you can decide, you need some very good information. Many people decide without analyzing the situation. I want to decide whether I'll go to the university or not. Should I do my master's degree or I shouldn't do my master's? Should I do PhD or I shouldn't do PhD? Decision, decision, decision. Okay. Some of the decisions, there's a subjective and intrinsic aspect to it. But usually, before you make a decision, it has to be systematic. There must be a systematic way of making the decision. And the purpose of what we are going to do today is to use the techniques, those systematic ways, needed to make the decision. And that's why we are here. So I want you to see yourself as a decision maker. Okay, a decision maker. Now we're going to look at two broad categories of decision problems. One, we will look at decision making under uncertainty. Now we've looked at that, under certainty. We've looked at that. Linear programming was under certainty. Integer programming, Go programming, and AHP. Okay. All of these are decision making under certainty. You are certain that you're going to get this product. You are certain. The only thing is about the number of it to deal with. The only thing is the number of fan you go and the number of fan choco that is needed to be able to produce anything. That is the point. However, we needed the thing is that it was going to happen. Then we have decision making under risk and uncertainty, which are more probabilistic. And we shall look at this. So I want you to understand some few things. One, the one making the decision is a decision maker. You have control over some items, but you also don't have some control over some items. I will use some scenario here to explain exactly what I mean. Okay. You have control over some items, and other items you don't have control. Okay. Now, all right, so this is a decision maker. There are certain things you have control. We call them DI. Those are decision alternatives. And there are certain things you don't have control over them. We call them SI. And those are known as the state of nature. So you control the decision alternative. That one you control. Okay? You control those decision alternatives. But then the state of nature, you don't control that state of nature. Now we're going to look at the difference between the two. Okay? What do we mean by the decision alternative? And what do we mean by the state of nature? Because once you can crack that, once you can understand that, the key factors are stored. Okay, so the state of nature has to do with certain factors that are outside your control. It could be the environment, the weather, the future event, inflation. You and I do not control inflation. You and I do not control any of the macroeconomic factors. Okay, so those states of nature you don't control, but then the decision alternative, they are under your control. Okay, they're under your control. You can choose to not to act on that decision, or you can choose to act on that decision. Now, so if you put the state of nature vis-a-vis the decision together, then you'll be able to come out with something that is known as profit or the payoff. The payoff. Okay. So you have the payoff, which is going to be the outcome of the decision you made. the net benefit. Now, remember I said net benefit. So it could be profit, revenue, cost, okay? But this is normally given in a payoff matrix. So you put it in a kind of a matrix. What that means is that you'll be having it in the forms of rows and columns. Rows and columns. You have it in something like that. So we are going to put all of this together and then look at the techniques to arriving at the decision. The techniques. Okay. So let's look at a payoff matrix. Okay, a payoff metric, we'll use that to be able to get the entire thing. The approaches we are going to use to decide are the following. We're going to use an approach known as the Maximax approach. This is sometimes called the optimistic approach. The maximin approach, that is a pessimistic approach. The Minimax regret approach, that is an opportunistic approach. The Minimax approach, the Howey's approach, the equal likelihood, and several more. But we're going to look at just 3. And by the bold future, you can see the ones we're going to look at. So let's take a practical example and then walk ourselves through it. This topic is a very, very easy topic. Okay, very easy. If you pay attention, you can crack it. Now I'm going to give this story without assuming any probabilities. Okay, without assuming any probabilities, and you will understand later. Kofi Wayo wants to decide among some investments. He wants to decide whether to invest in a building, apartment building, in fact, office building, or warehouse. Now, the future state of nature, that will determine how much profit Kofi Wayo will make. The future state of nature are good economic conditions and then poor economic conditions. So those are the future state of nature. Now the profit that will result as a result of each decision are what you see below here. So here you have what? You have an office building. This is an office building. Okay. So you have this as an office building. Sorry, apartment is there. You have an office building, which is also there. That is this. You have a warehouse. This is a warehouse. That is also there. And this woman is like an advisor to Kofi Wayo. And this woman has calculated more or less the economic reports when the situation is bad. This is a very bad economic report, okay, because the arrow is going down. And this is a very good economic report because the arrow is going up. Okay, now let's get into the mathematics of it. This is just a picture, but this is the situation itself. Now the apartment building, okay, apartment building that you see here, this apartment building is under good economic condition is going to cost $50,000. That is a return. Under poor economic condition, the return is going to be $30,000. Now, office building, under good economic condition, it will give you a whooping $100,000. But under poor situation, it will give you a whooping negative $40,000. Now, warehouse will give you $30,000 under good condition and $10,000 under bad condition. The first question is a very simple thing. What decision criteria will you select? Which of these alternative decisions will you go for under the Maximax approach? This is it, the Maximax approach, the optimistic approach. Now, I want you to rewrite this whole thing in your book because you're going to use that to be able to address the story that we are considering here. So take your book, like I've just taken my book. And what I want you to do is to write the situation. So here we have something like this. Let me take it to the side. Let's look at something like this, and then something like that. So these are the decision alternatives. Okay, you have D1, decision alternative 2, decision alternative 3. And then the state of nature, we refer it as S1, state of nature 2. Now remember, in this question, the state of nature was just 2. But then the state of nature could be more than 2. And the same way, the decision alternative can also be what? More than 2. Now, in this case, the decision alternatives are 3, but it could be 5, 6, 10. So what was the numbers? Well, we're told that under the state of nature 1 for apartment building, which is the D1, D1 is apartment building, you had 50,000 against 30,000 when the economic conditions were bad. I'm just removing the thousands, okay? And then we were told that under office building, if the economic conditions were good, we had 100,000. If it was bad, we had negative 40,000. And then the last one was warehouse. If you should invest in warehouse, under good economic condition, it was 30,000. Under bad economic condition, it was 10,000. So, question 1. What will be the decision criteria under the Maximax approach? Now, I want you to appreciate what this Maximax approach is. So I'll take you back here. The Maximax approach simply means that investor has an optimistic view of the future. Okay, so the person has an optimistic view. That person is choosing the best of the best. So he believes that the future is really good, and so he's going to select the best of the best. Now, what is the first best and what is the second best? The first best is that person is going to now categorize these results under the different state of nature. So you look at the first best is the column 1. So he will select, he will check whether, when he looks at the column, which columns gives the biggest return, okay, for each state of nature. So he will look at the first state of nature like this, all right? So when you look at the decision alternative D1, he's going to select between, some of you can just jump the answers because this is an easy one. If you don't follow the approach and you go through quickly jumping the answers, when the things are plenty, you see that it doesn't work that way. Okay. So such a person will go for the best of. So when you look at the first decision, okay, he has a choice of choosing between 50 and 30. And he is going to select what? He's going to select 30. So under the Maximax, I will call it up here. I just want to use some number. Under the Maximax approach. Okay. Maximax approach. He is going to select the 50 first. Under the decision alternative 2, between the 100 and the negative 40, which one is he going to select? Between the 100 and the negative 40, which one is he going to select? He's going to select the 100,000. So you write 100,000 here. And under decision alternative 3 is going to select which one? Under decision alternative 3 is going to select which one? 30,000. So you write 30,000. So now he selected the best, okay, based on the state of nature. Now, out of these, which one is he going to select? Okay. That is a Maximax approach. So the word Maximax, the first max is selecting from the decision alternatives across the state, and then finally choosing which decision alternative to go for. And he's going to go for this one, the 100,000. So using the Maximax approach, the best decision should be to buy office building. Okay, using the Maximax approach, the best decision will be to buy office building. Now, please note that the Maximax approach is also known as the optimistic criteria. The optimistic criteria. So when you go through all that we went through, you will see that that is it. Okay, that is how that person makes the decision. So you conclude normally by saying that the recommended decision is office building. Okay. Recommended decision is office building. All right. Now let's go to the next criterion. The next criterion is known as the pessimistic approach. The pessimistic or the maximin. The maximin criterion. That person is a pessimist. You know, those some people who are always conservative, you know, nothing is going to work. Let me take it cool. So such people choose the best of the West. Now look at this word. It's not the best of the best, but the best of the West. The best of the West. So such a person, because he doesn't want trouble, let's go back to our situation. Because such a person doesn't want any trouble, let me create one column because you're going to calculate the best of them. Okay. So these are the maximin. Maximin. The min is important. So such people, what they are going to do is that they are going to take the best of the West. So such people, they are going to select the worst case scenario in each decision. The worst case scenario in each decision. And the worst case scenario, okay, are those under the S2, the good economic condition. So between the 50 and the 30, such, I'm just going systematically for you. Because somebody will say that I didn't understand. So between 50 and 30, that person will select the worst case scenario, 30. Between 100 and negative 40, the person will select what? Negative 40. He doesn't want any wahala. Between 30 and 10, the person will select 10,000. And now that he's got the worst case scenario, he is now going to select the best out of these worst case scenarios. He's going to select the best out of these worst case scenarios. So which one is he going to take? Which one is he going to take? Which decision alternative is he going to go for? There's no question that the maximum out of the minimum is 30. So the decision alternative will be what number? What D? What decision? D1. Okay. So it's going to go for 30, and that is D1. Now, in the first situation, he went for D2, don't forget. Now, in this situation, he's going for D1, which is apartment building. So the first case, he went for office building. Now, using the maximin or the pessimistic. Those words, you got to learn them, because sometimes they can be confusing. Okay, fantastic. Now we are ready to go to the third criterion. The third criterion. And this third criterion, and by the way, if you don't understand, you just let me know. These are easy bits. As for these easy bits, just let's flow. When we are done with the easy bit, I'm going for the difficult ones, you can trouble me. Okay. So let's go for the third scenario. The third scenario is the Minimax regret approach. Such people are not optimistic, they are not pessimistic, they are opportunists. You see, there are those people who actually look at what they could have gained in the stock market. Let's take a typical example. In the example that we are looking at now, if the investor bought the apartment building, and that's what we did right now, okay? If the investor should buy the apartment, only to find out that the future economic conditions were not that bad after all, as he thought, what will she feel? What do you think that person is going to feel? He will feel what? I want a certain English word. What is he going to feel? Having seen, he's going to feel regret. He's going to feel regret. Okay. Regret not buying what? Look at yours. Okay, if you want me to show you mine, let's go and let me show you mine. So if he had selected this economic condition, okay, because he thought that situation was going to be bad, and so he went for this, only to realize that economic conditions were good. And so now he feels regret not getting what? Not getting the 100. Okay. Not getting the 100, not buying the office building. That's how he's going to feel. He's going to feel that sort of regret for getting to that situation. Now, question is that the degree of the regret will be calculated as how much? The degree of the regret will be calculated as how much? It will be calculated as what he has now and the extra he would have gained. Okay. What he has now and the extra he would have gained. How much is that? What would be the degree of regret? The degree of regret, okay, is going to be 100 minus 30, which is 70,000. Okay. That is going to be the degree of the regret. But you see, such a person, he will feel. And so all that I told you, that it hasn't happened. It hasn't happened. So the opportunistic person will calculate his regret first. He will try and calculate the regret for each decision he should take. And so he will form something that is known as the regret table. The regret table. So I'm going to show you what the regret table is calculated as. Okay, there's a formula for the regret table. The regret table is given by this formula. It's given by Rij equal to the absolute value of Vj star minus Vij. The absolute value of Vj star, write it down, minus Vij. It's very simple, to be honest with you. The Vj star, you see the word J is always looking at columns. Keep this in mind. The word I is always looking at row. I is always row, J is column. So if you look at this one, 50. Okay. If you look at the 50 here, the 50 is going to be something like Ij. Okay, Ij. So if it is this row 1, it's going to be 1 and then column 1, 1, 1. That's how it's going to be, 1, 1. Now, the Vj star is looking at, when you look at the columns, the highest value in that column. Now, remember, these payoffs are profit. They are profit, they are gains. So we are looking at, if they were cost, we'll be focusing more on the lowest values. Okay. But please know that they are. Now, so Vj star is come back to the original situation here, and you are going to calculate your Vj star as the highest value in each column. Okay. So the first one is going to be V1 star. That's how it's going to be, V1 star for the column 1. And the second one is going to be V2 star for the column 2. So you find the highest value in each column. So what is V1 star? What is V1 star? You can tell us. What is V1 star in the original? That is 100. So you put it down, 100. And what is V2 star? What is V2 star? V2 star is not 100. V2 star is what? 30. Very good. V2 star is 30. So now we know that having gotten that, you should now be able to calculate the regret table. And please open your eyes and your mind as I'm about to work with you on how to calculate the regret table. Now, the regret table is calculated in the same way as the original table. So watch it. The original table was like something like this and something like that. Okay, that was like the original table. Okay. Now, how do you now? So the original table, you have D1 here, you have D2, and finally you have D3. Now then you had S1 and then S2. Okay. So we are going to find a number for each one of these. So we're going to find a number for the space here, a number for the space there, a number for the space. That is corresponding to the 6 spaces in the original table. But those numbers are going to be regrets. Each one of them is going to be regrets. How do you calculate the regrets? It says that take the highest value in that column minus the value in the cell. So what it means is that if you go to the first one here, okay, the first one, you're going to take the highest value here. The highest value, we've already taken them as 130. Okay, so the first one is going to be the highest value, which is 100 minus the 50. And you write the absolute value. You write the absolute value means that if it is minus, you make it all positive. Okay, all right. And you kind of put a bar in front, but we don't want to write a bar here. So the first cell, which is going to be R11, okay, this one is going to be R11. What to be the value of the R11? Who can tell me? What to be the value of the R11? R11. That's 50. Very good. Okay, so you got 50. Now, let's finish that column. What to be the value of R12? Okay. R12. I hope you understand why I called it R12. It is, oh, sorry, R21. Again, this is a clear indication that you always have to be careful how you write. It is the row 2, column 1, R21. Okay. So what would be the value of R21? 0. Very good. What would be the value of the next one? Is what? It will be R what? The next one will be R what? Now, some of you are writing negative. It's never negative. Okay, it is 70, R31. Very good. Okay, so that will be 70. 70. Okay, now who can tell me the next one? R12. What to be R12? What to be R12? R12 is 0. Thank you. What to be the next one? The next one is R22. R22, you have to be careful. R22 will be what? Somebody says 60. No, it's not 60, it's 70. Somebody doesn't know why it's 70. Remember, it's 30 minus 40. 30 minus 40 is 70. 30 minus 40 is minus 70. Okay, now let's go to the last one, R31. R31. R31 will be 20. 20. Very good. Ladies and gentlemen, this is what is known as the regret table. Okay, that's what, let me just write down. Okay. So this whole thing is a regrets table. So you just calculated our regret table very nicely here. The next thing we have to do at this stage is go back and then find out the answer. Because remember, let me just take you back. It's called, the approach we are using, we are dealing with is known as the Minimax regret. Watch the word, Minimax regret. Minimax regret. So that word regret here means that, remember, Minimax. So first you need to get the maximum regret. That's a max. Then you find the minimum of that maximum regret you found. So for each table, you have to identify the maximum regret for each decision alternative, okay, the maximum regret. So you look at decision alternative 1, D1. What is the maximum regret there? So let me call it up here, maximum regret. What will be the maximum regret for that first one? What will be the maximum regret? Because we have regret of 50 and another regret of 0. So we'll take the regret of 50. Okay, the second one, what is the maximum regret? Somebody has seen everything, so the person is just writing all the answers. Maximum regret is 70. And then the third one, what is the maximum regret? The third one to the maximum regret is also 70. Very good. So now we've been able to calculate the maximum regret. The last column you have to now calculate is the minimax regret, which is the one you're looking for. So out of the maximum regret, you're now going to select the minimum of the maximum regret to calculate. So this is called minimax regret. Minimax regret. And so you just take the minimum regrets, and that is what? Out of those regrets, which one is the minimum? So that's an opportunistic person. The minimum is 50. The minimum is 50. So using the opportunistic approach, using the minimax regret approach, the recommended decision is to go for what? Warehouse, office building, or apartment. Apartment first, office building second, warehouse third. Which one? D1. Okay. So based on this, you can now conclude and say that the recommended decision, using this approach, okay, using this whole minimax regret approach that we have done. Everything is in the slides, by the way, but I've just made it simple in the using the minimax regret approach. Okay, you have been able to identify the best decision is to go for apartment building. And the reason is simple, because the investor will get the least regret of 50, the least regret of 50. So that is how you compute, things related to this approach. That is how you use the maximax, the maximin, and the minimax regret approaches. Okay. Any questions?